Reliability is the probability of performance, the likelihood of success. Redundancy always increases reliability. Redundancy helps reliability. And you can see that in this particular question. A component has a reliability of 98%. Okay, it's got a 98% probability of performance. And it's backed up by a redundant component with the same probability. I always draw these situations. All right, there's some important component, like say a processor. It works 98% of the time. If it failed to work, there is another one that would go active and take over. That's what the system looks like. Most of the time through the first one, but maybe through the second one. What is their combined reliability? All right, now calculating the effect of redundancy. The easiest way to assess the effect of redundancy, you want to know the reliability of the overall system, is to first calculate the probability that the system will fail. Okay, what we want, right, their overall combined reliability, the easiest way to find that is to first calculate the opposite. What is the probability that they could both fail? Oh, all right. Now, if the probability that they will work is 0.98, that means the probability that any individual one of these two would fail is 0.02, right, or 1 minus 0.08. What we're asking is, what's the probability that both of them would? That's a joint probability. The probability of two or more things happening at the same time as you multiply their probabilities together. So, little scratch work here. Probability of both failing. Well, that's 1 minus 0.98 times 1 minus 0.98, or like I was saying, basically 0.022% times 0.022%. Put that in my calculator to get a very, very small number back, 0.0004. That is the probability that they both fail. Reliability is the probability of success of the system. So it's basically everything else, because this is either one works, one doesn't work, and the next one works, right? Or either they both fail. Ooh, that's an unlucky day. Okay, the probability that they both fail is 0.004. 1 minus, that's the probability of everything else, and that's performance. It would be reliable. 1 minus the probability that they both fail is a rather handsome number, 0.9996, or 99.96%. Each one of these components only works 98% of the time, but notice in this redundant system, the system works 99.9% of the time. The redundancy enhances the reliability. Now, similarly, a processor has a 10% probability of freezing, at which point an identical backup processor is activated. What is the probability that they both freeze? This is actually an easier question than before because it's a similar system. You could draw this with the 10%, but you have to be careful. This is the probability of failure. What's the probability that they both freeze? Oh, the only thing that we have to do is to take those two probabilities and multiply them by each other, because it is the probability of both of those events simultaneously. It is a joint probability. Okay, so it's 0.1 for 10% times 0.1, or 0.01 is what should appear on your calculator, or 1%. So, in this two-processor system, each processor, there's a 10% chance, 1 chance in 10, that it'll freeze up, but the probability that the system freezes up is only 1% because of the two acting as redundant elements.